we can get started now. So hi everybody, welcome to our webinar today. We're going to be discussing EnerGuide energy studies and how to read and interpret the results today. So my name's Alwyn Rutherford. I'm the Climate Change Program Coordinator at the Fraser Basin Council. And today my colleagues Erin Peterson and Elena Chia are also here to help out from the Fraser Basin Council. So if you have any technical issues or questions, just reach out to Erin and Elena through the chat box and we can help you get things resolved. So now I'd like to introduce DeAnne and Trevor, who are going to be speaking first. So DeAnne Lythall is the Executive Director of the Fort St. John Native Housing Society. She grew up in Kamloops, BC, and her mother's side is from Sturgeon Lake Cree Nation in Alberta. Trevor Norris is a member of Kitigan, Zibi, and Anishinaabe First Nation. He's an experienced project manager, and he's specialized in the field of Indigenous, social, and low-income housing throughout his career. He's worked in this field in Nunavut, the Northwest Territories, Alberta, and British Columbia. And Trevor has an educational background in project management, public relations and fire safety, and emergency management. So welcome, DeAnne and Trevor, and please go ahead with your presentation. Just let me know when you'd like me to change slides.
Hi, I'm DeAnne Lythall from Fort St. John Native Housing. We have 27 homes here in our portfolio, which is we house for safe, culturally safe and affordable homes for our Indigenous tenants. And we also have a tenant relations that popped in today, so she can add some stuff. Her name's Lisa Appaw. We also work closely with AHMA and obviously with Trevor Norris right now. I think Trevor's probably going to be the light in this webinar to be able to explain more of the programs that we have been doing that we've successfully done, and also with Arno as well with our blow testing. So if there's anything else that you'd like me to add, Trevor, please just let me know. So did you want to start off with our with some of the projects that we have completed and what we are about to do, Trevor?
Yeah, absolutely.
Thank you.
So in Fort St. John, as with almost every Indigenous housing society that we work with, funding can be a very big barrier to doing any work. So in all of our efforts, the EnerGuide assessments are a great tool in terms of helping us to determine where can we cut down energy usage, especially in communities like Fort St. John that are so reliant on natural gas. And, you know, sometimes in the winter, you lose power, you got to rely on a backup generator or whatnot. So through the assessments, we've been able to determine here's where we can reduce power or energy consumption, whether that's electricity or gas, and therefore get some rebates that'll help us do additional work. Recently, we went through and replaced, I believe it was 11 very aged, inefficient hot water tanks with some new ones. Other things that we're looking at doing for our next project are windows, insulation, fixing up some foundations, which will, you know, if you keep your basement warmer, you're going to have one, less power usage. Two, you're going to have just more comfortable, warmer homes in general. No one likes getting up in the morning and stepping onto a cold floor. So through all this, we're gaining the benefit of, you know, we're helping with the environment by reducing natural gas usage. We are making the homes more comfortable for tenants by keeping them warmer in a very cold climate. And three, we're getting rebates where possible that'll allow us to do further work that might not be directly related to energy, but is still essential. So the building condition assessments, we have at AHMA, we have two building condition advisors that essentially travel all over the province, having to enter homes and assess each individual component of a home. And obviously that does help us to determine where we can do other projects, as the slide notes. It allows us to know what our worst houses are, what our best houses are, whether that's single family homes like in Fort St. John or multifamily units like we have across the province. And it also, as we go through those, it does allow us to say, hey, where can we get energy assessments? Where do we need hazmat assessments? And that all kind of comes together to help us with capital planning and even portfolio planning to set the societies up for a better future. The energy studies, I've done these in multiple communities, but focusing on Fort St. John, again, they've allowed us to determine where can we reduce energy consumption and where can we transition from gas to electricity. BC's obviously great because we have so much hydroelectricity. We're not like Alberta or Saskatchewan, where they do rely so heavily on fossil fuels. So when we can electrify, we can identify that. When we can reduce energy usage in general, including reducing electricity consumption, because when you are reducing your natural gas, you are increasing your electricity. So if you can also reduce the electricity, you can bring the overall energy usage from all sources down. And again, it all goes back to funding as well. Every incentive you can get, whether that's from organizations like BC Hydro or Fortis BC or some of the credit unions, BC Housing bases a lot of their funding programs on, there are funding programs that focus on energy consumption. CMHC has similar stuff. And overall, just, on all ends, it's a win-win-win situation.
One of the things that we were noticing is that a lot of our tenants had those old school window air conditioners that were like causing bills to really skyrocket. DeAnne and I did a little bit of research. We did applications to BC Hydro. They gave us new energy efficient, I think there was 10 of them last
11.
year. There was 11 last year that we got that were gifted to us through BC Hydro of the energy efficient ones. And we did the applications for the remainder of the houses in September. And we're hoping that before summer here, we'll have the rest of those air conditioners in. And it was just an application form for each individual house. And they were given to us, which I do know for sure that I've had 2 tenants that didn't even have a window air conditioner, and their bills did not even change with those energy efficient air conditioners that were gifted to us.
And as the technology continues to improve with heat pumps, the hope would be that eventually heat pumps could be a very valid source for heat and cooling in communities like Fort St. John.
Yeah.
The technology's slowly getting there, but there have been some performance issues when you go to -40. So these air conditioners are very much needed, because people might think of the north as a place that's always cold, but Fort St. John, I've been there and I have been in a t-shirt and shorts and sweating anyways. So
Yeah,
it's really important to have solutions both for heating and cooling.
Yeah. +30 to -50, that's our weather here. It's kind of a big gate there.
Okay, well, thank you so much. Next, I wanted to introduce Arno, who's going to take us on a bit of a deeper dive into the project and the energy audits process. So Arno Bredenkamp is the principal consultant and owner of Greenspace Ecoconsulting services. He's an energy manager, a certified energy advisor, engineer, and entrepreneur. And for the past 15 years, he's performed energy audits in the Okanagan, Shuswap, West Kootenays, and Vancouver Island. And he's completed more than 1,000 EnerGuide energy assessments at privately owned homes, as well as larger energy efficiency consulting projects for First Nations and for Indigenous housing societies. So thanks for being here, Arno, and go ahead with your presentation.
Yeah, thank you very much, Alvin. It's nice to do this in a sort of a run over all the EnerGuide rating questions, but also I really appreciated DeAnne inviting me to come up to Fort St. John right when Site C Dam started producing electricity. It was a wonderful experience. I will remember it for a long time. It was quite impressive to see that big dam starting to push out the electrical energy that we so dearly need. It was a nice experience. Thanks, Alvin and Erin, for allowing me to speak. So basically, what I want to just touch on is what the process of EnerGuide ratings entail, and then also the value that can be obtained from the different outputs. That's part of a normal EnerGuide rating assessment. So on the left-hand side, I've got the sort of the output. Basically, it is we produce a bunch of PDFs, which is just documents, a label, and then also a report. And we usually accompany this with photos taken during the site visits. And then also we include infrared photos that's also taken during the site visit while doing the blower door test. And I'll discuss that a little bit later. So all of those things are given to either the homeowner or to the authority that actually request the assessment project. And now in this case, it was all given to AHMA, and the report was also supported with spreadsheets and a little bit of executive summary to give my overall impressions of the project and recommendations in terms of funding opportunities. So the project scope, it was originally put out through the RFP process. It was like on a tender. I won the tender and ended up doing 21 home assessments last year during September. The reports are usually done through a system that is managed by NRCan, Natural Resources Canada, and we upload those data sets to them for their quality control. And we also work through a service organization that has quality control responsibilities over me as an energy advisor. The reports include recommendations and then also analysis of possible grant opportunities. So all of this is based on a process called the EnerGuide rating system, ERS system. And this is a system that was designed and managed by Natural Resources Canada. And it's like a labeling and performance testing process that would normally be used to test components like, white goods, appliances for the kitchen, or any other system. So there will be a label attached to this item, and in this case, it's attached to the home that we rate. The system wants to achieve energy literacy under the stakeholders, so it wants to sort of try and make people more aware about where energy is consumed and why the energy is consumed. So with other words, what is burnt, like is it fossil fuel or electricity, and then what is the reasons for it. The other output is also to help give performance information about housing to the government levels. With the words, it will also help people to say where are homes lacking and where should money be spent. The focus would be to reduce cost and increase comfort, and also increase health, because comfort and health is sort of the two horses pulling the wagon. We want to make sure that air quality is good and heat and cooling comfort is achieved. And then on the other side, also reduced in the environmental impact of housing in Canada. So it will show what the greenhouse gas impact of this specific home is on the overall picture. We use energy simulations in absence of more detailed data to derive an EnerGuide rating. An EnerGuide rating is basically the energy consumption of that home over a year period. HOT 2000 is just a program that was written by the people at EnerCan, and it uses the envelope information of a house. Envelope means everything that enclose the home, with other words, walls, ceiling, windows, basement insulation. And it also models the heating, cooling, and water use efficiencies that we capture from the labels in the house, or sometimes we also have to dig a little bit deeper to find energy efficiency data on the specific components by searching webs or lists on manufacturers' websites. The last little bit is also an interesting one. They talk about internal heat gains, and that is the heat that we generate as human beings while living in an enclosed environment. We heat the environment, and that heat can either be good, specifically during the winter, but that heat needs to be rejected during the summer months, and it might lead to an increased cooling load in a house that needs to be managed through air conditioners or other systems, ventilation systems. So the ERS system and the H2K, HOT 2000 systems, are used in Canada to do building energy simulations that can be used for the modeling of new homes before they're constructed, but also the renovation and retrofitting of existing homes. With other words, we can use it to predict heat losses and heat gains, and we can also use it to predict changes in the house if we do upgrades or renovation improvements. So the next item is focused on what is produced with this HOT 2000 program and what is the output of the EnerGuide rating system. So what you've got in front of you is an EnerGuide rating label. That is a label that you would normally find on the electrical panel of a home, or otherwise it might be, like in DeAnne's case, it might be somewhere in our files, and it can be used to reference this home with other homes. So what we can see is obviously the date and the location of this energy assessment, and then a bunch of numbers. So the number that I'm pointing at, the 128 gigajoules per year, that is a calculation of the home's energy consumption if it's built today or this year, using current building code requirements. So it's sort of the baseline or the comparative number for this home. Now, in this case, we can see that the home's EnerGuide rating, as measured or simulated, was 138 gigajoules per year. So it's a little bit more than the typical home EnerGuide rating. So this shows us there's a little bit of room for improvement just to get to the building code requirements. So that this would indicate that this is a house built to a previous building code requirement, or maybe it was not that well built. On the label, you will also see the best energy performance. And in our case, we always try to get to net zero. Net zero is sort of the gold standard or the dream that we have to make all homes zero consumption by having renewable energy linked to that specific home. So for instance, if we add solar panels or wind generation to this home, that number will be reduced to zero, and we will see it on the label with overall renewable energy contributions being equivalent to the consumption of the home. It also gives us an idea of where the heat or cooling energy is used. So we can see that most of the energy consumed by this home is basically used for heating, and that's quite common in Canada. We are a heating dominated area, and therefore we tend to focus on heating more than on cooling. However, cooling is still quite dominant in this house. 6% of energy consumption is due to cooling, 21% is due to water heating, and then there's a little bit, 13 and 9, which is basically a standardized lighting and appliances and other electrical loads that's modeled. And that's usually the same for all homes, because all homes would have some appliances included as consumption components. And it's also true that we model these homes with the same number of occupants. And I'll also sort of make a joke. So in Canada, we have 2.5 people living in the homes on average. So it's 2 adults and a child that's usually living in our homes when we do the modeling. On the next slide, I show the front page of the renovation upgrade report. Now, this is the report that basically is the main output that we as energy advisors will put our effort into. We will then list possible upgrades in the report, and for each upgrade, a calculation will be done on what the savings would be if this upgrade is implemented. And it's called your energy efficiency roadmap. And we start with the most obvious things and then move towards the less obvious things or the less important things, going down or to the right. Now, air tightness improvements are always very important because it's usually a low cost or a no cost upgrade. But then attic insulation and wall insulation is also quite important because you want to insulate your envelope before you start adding better or more efficient heating systems, because it's better to consume less by having your heat loss or cooling reduced before you want to try and implement systems to cool or heat the house. So on the next slide, I have an example of one upgrade that's recommended, and in this case, it's insulate attic. We describe what should be done or what is recommended. Then there's a list of resources or basically guides that can be used by the project planner. In our case, it would be the homeowner, or Trevor in the case of AHMA. He will look at this and then also look at the energy advisor's comments. And that this writing in the box is what I added to the report that's a little bit more detailed and also would guide the person that do the upgrades to maybe be a little bit more detailed. And I would also maybe add tips and tricks that I've found through experience or basically during the site visit. So it's an important one to look at the things that's in the box, because that's basically the EnerGuide rating advisor's inputs. It's not the standardized cookie cutter report that was generated by the system. So the last page of the report give us graphs where the heat loss in the house happens. So we can see out of the top a bar graph, the longer bars is where the most heat loss is happening. So this house has got insufficiently insulated basement walls, and that's why it's like a crazy big bar that's created by the basement losing a lot of heat. We also have the main walls, windows, that's losing heat, but that's the focus area. And if we go to the lower slide, we can also see, and sorry, the two bars, the black and the yellow, is before and after. The before is black and after the upgrade is yellow. So we can reduce the heat loss through the basement walls from a 93 to a 22 gigajoules per year by implementing the recommended upgrade of adding insulation to the walls. And if you do that, you will see that there will be less energy use because the space heating energy consumption will reduce substantially from 141 gigajoules to 16. So it's quite an important one to do your envelope improvements, your insulation improvements, before you start looking at your systems, because by doing the insulation first, you might end up with a smaller requirement on your mechanical systems. So you can install a smaller heat pump or furnace after you've added the insulation. So the next, this is the outputs that's normally given during or after an energy assessment. In the case when we do multiple assessments, like in a project that we did for Fort St. John's, I compared, and the summarized findings are quite interesting. The highest consumption per home was 194, and the lowest was 94. So there's a difference of nearly 100% or 50% of spread over the homes that we did. And it's because some of them had only a little bit of insulation, and some of them were recently renovated and quite nice. We also can compare with typical new homes. So we see that 23% on average, so homes were 23% higher than the typical new home. I also analyzed the homes by looking at specific upgrades, and that's also shown. So space heat upgrades and tankless water heaters, we can reduce the consumption by 67%. And if we do an electric heat pump, space and water heater, we can reduce it by additional 6% to get to 73% of energy reduction and nearly 98% of greenhouse gas reduction. So quite a lot of upgrades are possible in these homes. For the project, I also used the Excel spreadsheet to basically give an overview of where the priority items are. And I know this slide is very, very detailed, but it's just an easy tool to use to look for the red spots and focus on those addresses. So I've got addresses on the one side, and then all my performance indicators and after upgrade savings tabulated. So we can use the reds to focus as focus areas, and on the right-hand side of the graph, it's basically a tool for Trevor to focus him and help him sort of do his calculations to see where he might have funding opportunities. Because in many cases, with authorities like we're talking about, we are dependent on getting funds from some programs that the government has got running to help with the funding of upgrades. And we need to meet the requirements of those programs in terms of performance criteria, improvement criteria, reduction of greenhouse gases to get the funding. This is sort of a tool that I would use, but it can also be used as a starting point for the project manager to sort of guide him in his funding of applications. So what we're doing now is looking at the process. So just to recap, the site visit include data collection. So we go around, taking photos of the house, measuring areas, volumes, checking the R value and the amount and the type of insulation that's installed, capturing the type and the energy used of mechanical systems. That would be water heating, ventilation, cooling. And then we do a blower door test. Now, the blower door test is done by mounting a frame in one of the doors. That's this red thing right in the middle of the slide. So it's a frame mounted with a fan that's calibrated. So if we suck more air out of the house, we will know how much air is entering the house, and we will then derive indices out of this test. And ACH50 is one of the main numbers that's used in reports. And I just want to maybe spend a minute on discussing this. So first of all, ACH50 stands for air changes per hour at 50 Pascal depressurization. And what it really means is we try to predict the number of times that the home's volume, the whole volume of the house, needs to be reheated when there's a pressure difference of 50 Pascal between the inside and the outside. Now, 50 Pascal is the pressure that we would experience when there's a 50 mile per hour wind blowing. So it's a wind that blows into the house and then causes air to move out of the house or into the house. Now, obviously, we can't do that by producing a wind on the outside, but we can depressurize the house. And we depressurize the house to 50 Pascal. 50 Pascal is actually very little. I try to equate it to the wind that you would feel if you drive in a sort of at the middle of the town where there's a speed limit. So it's a slight wind that you would feel on your hand if you put your hand out of the window while driving the car. Not a lot of pressure, but quite substantial. If you think of it that very, very well-constructed homes would still have ACH50, air changes per hour at 50 Pascal rating of maybe 2.5 or 3. That is actually the current building code standard. 2.5 is what we want to achieve. But most homes would have a number sort of on your single hand between 2 and 5. And then the older homes might have a number ACH50 of above 5 to 10. And then the really, really bad homes would have like 12 or 15. And those are usually homes with open crawl spaces or seriously damaged envelopes. Now, the next item that we do, and it's usually to try and determine where the air leakage happens. In the olden, maybe 10 years ago or so, we used to do it with a smoke pencil. And it's quite time consuming to walk through a house to try and determine where the leaks are by waving a smoke pencil around and then see where the smoke goes. Now with the availability of thermal cameras, FLIR cameras that you can attach to your phone, like I did on the right-hand slide, you can see where the heat is actually escaping or where the heat is coming in by looking at a thermal picture. So a thermal picture is basically just an infrared scanner that's attached to your camera, and the camera then overlay the thermal picture onto your phone's picture that's captured through the visible camera. So I use these things to then come up with the recommendations. If we know that there are specific heat loss areas, you would then focus on those and use the thermal pictures as a tool for energy efficiency recommendations. but it's also a really, really good tool for project managers or installers or maintenance staff to help them understand why they do certain things and why it's important to basically focus on, air movement as a primary focus when you try to do the low cost or no cost upgrades. The next couple of slides are based on that principle. So I'm going to just show you a few of the slides and maybe discuss them. So first of all, the color scheme that I use is the darker blue areas are cold and the warmer orange white areas are hot. Now, what we have on the left-hand side is a photo of the bottom of a door taken while I'm running the blower door in depressurization. So air is being sucked out of the house, and therefore the air, which is in this case cold air, is trying to come into the house, and it's seeping in under the door sweep that's non-existent. So this door sweep is either deteriorated or it's gone, and we can see the cold air being pulled in from underneath. So the recommendation is replace your door sweeps, add weather stripping. The middle one is quite funny. Lisa and DeAnne already discussed that. This is one of those terrible air conditioners that had lots of air movement around the pipe. And this is a cardboard that was put in the window. And you can see it's got very little insulation if you compare it to the wall around. So this is an air conditioner, and that's a window with a pipe going through. And we can see not good. If you have that system installed to cool the house, because the cool air will just go out again. And in this case, it was cold outside. So we can see the cold air actually being sucked into the house or pulled into the house because of the insufficient insulation of the tube. On the right hand, this is a photo taken of a basement wall. And we can see the joist or the header areas are very, very leaky. Hardly no insulation, and lots of air movement around that. And that's because wood meets concrete, and those boxes are very, very leaky because the gaskets between the wood and the concrete has most probably deteriorated. So the recommendation here would be to install new insulation and properly air and vapor barrier it. We can also see that this area below grade, which doesn't have insulation, is also leaking heat like crazy. So by extending the insulation to the ground, right to the bottom, you can reduce that heat loss quite substantially. So another one that's quite interesting, we have a concept called thermal bridging. And thermal bridging happens when you have different R values or insulation values in an assembly. Like this is a wall, and you can see the dark lines running down, and those are due to the wooden studs that has a lower R value, less insulating value than the stud bays that were insulated. We also see the corners and the ceiling to wall edges that's quite dark because of heat loss happening. And the heat loss happens because heat would go through the where the R value is the lowest. The path of least resistance is another way of putting it. So this can be reduced if we add insulation to the outside of a wall, with other words, wrapping the whole house with external insulation. And that will then insulate the studs on the outside and reduce the heat loss through the assembly. These two photos are actually a normal visual photo, and this is an infrared photo of the same basement. The insulation was removed over there, and we can see the impact it has. So all the heat would basically sneak out there. So the insulation that you have there is really wasted because once again, the path of least resistance is through that area. So it's important to try and extend insulation over the whole of a basement wall and also repair it, because basically this was insulated and it was destroyed or removed or damaged by people living in the house, and they don't know that it's important. So when doing the blower door, air is sucked out of the house, and this is a photo of the attic hatch. So what we see here is cold air coming in around the attic hatch, and it's quite substantial. And it's so easy to prevent, because you basically need to just add a $2 value of gasket around the attic hatch to prevent that from happening. So this is quite an interesting one, usually for maintenance workers to see, because it's something that's quite easily, just ignored. The middle picture is I projected the infrared photo over the visual photo, and beautiful wall. Everything looks very, very normal, except you can see those terrible spots in the corner and above the window. And I believe that is because of moisture damage in the walls that caused that low R values. And by the way, DeAnne, don't worry, this is not one of your homes. This is one that I just snuck in because it gave such a nice picture and would help people understand what you can achieve with the EnerGuide rating using infrared photos. So this is a photo taken at another home, but it's quite obvious that this needs to be fixed, because otherwise it can lead to structural damage and other things, mold, whatever. This is also quite an interesting picture. It's a picture of a ceiling area where a pot light was installed, and the electrician removed insulation and he never replaced it. So now we have a new LED pot light there that might be super efficient, but the heat loss right next to it might cancel out all the savings. And what you really need to just do is ask electricians or people that do work in the attics to replace and repair the damage that they do while crawling around in the attics. So another picture, kitchen, beautifully renovated, but gaps in the wall because insulation was not replaced when they did this a kitchen upgrade. Middle picture is a bay window, quite common. That bay windows would have insufficient insulation in the bottom and the top part of the window assembly that's installed in a rough opening. So a window is taken as if it's good, but in actual fact, it's a really, really bad assembly, because heat loss is quite substantial through the bottom and the top. On the right hand, also a picture taken in another home, but was quite interesting. I thought this is a beautiful renovated home, and I walked around and I found this in the main bedroom. So it's the main bedroom bed right there, and this big black area behind the headboard is the wall facing the garage. That was this damage from the garage side. They had water damage in the garage. They removed insulation in the garage wall and they never replaced it. And now there's like a area of insufficient insulation behind the person's bed. And they complain about feeling drafts and cold in the bed, and they wouldn't know because it's basically insulation that's missing in the wall. You can only see it if you use a thermal camera. So my final recommendations would usually also be to say, all right, what can housing associations do? What is their focus areas, and also what they can maybe include in their project planning? Now, what we've found is older space heating systems needs to be replaced or at least maintained. And by having a look at the different systems, you can see if there's problems coming up. And in this case, you can see there was combustion gas that is condensed, and then it drips back into the furnace, causing rust or condensate problems. So that might be a focus area to make sure that venting is taking place properly. In the middle slide, built, well renovated home, except that the insulation panels that were installed around the basement wall, external insulation around the basement wall, came loose. And that would allow cold air to be in contact with the basement wall, and therefore heat loss would take place to those areas where the panels are moved. And all of the rest of the panels that were installed are basically, I don't want to say useless, but they're not really performing their function because the heat loss happens through those areas. And it's very easy to repair. You just need to push them back and put something, some form of adhesion between the panel and the wall, and make sure that they don't open up in the future. On the right-hand side, we can see this window is a little bit skew, and it happens because the hinges on this window can't withstand the constant opening and closing of the occupants. So it's most probably in a high-use location, or it could be that the hinges are just forced and they're not properly cranked open or closed, or maybe they're damaged by reckless use. And my recommendation there is to be careful to use those windows that can't withstand the operating conditions that they are deployed in. And that's sometimes recommendations that we can only find if we go back and actually do a post retrofit energy assessment. So that is an energy assessment that's done after upgrades have taken place, which I was given the job to do in this case. We could also review the houses that were really good and learn out of those. Thank you. This was my last slide, and I'm now handing over to Alvin again. If there's any questions that came in through the chat, maybe I can address those.
Great, thank you so much, Arno. I did want to quickly go back to DeAnne. If you wanted to tell us just a little bit more about where the project is now for the Housing Society and how these results were used. Please go ahead.
So actually, we work closely with Trevor and Tuan as well, Archie with AHMA, with these projects. So with the energy efficient studies that we had about 3 years ago, plus we've had hazmat studies. We've also had radon testing, as well as we worked closely with, like I said, AHMA as well. So we have the hot water tanks that just went in from gas to electric, and then also with the you had the air conditioners in there a couple of years ago. But Trevor probably can touch more on what our next steps are here. Trevor.
Yeah, so we have just recently secured some funding to do some work. Right now, between DeAnne and her staff and myself, we are determining exactly what we're going to do with the funding. The EnerGuide reports are for sure going to guide some of this, and then we're also planning another future funding request that will address things that our current one doesn't. In the near future, we're expecting to do that. The hot water tanks that were recently replaced, that I'm not quite sure where we're at in the process of getting some rebates for those, but we're applying for rebates, hoping we can get some money back for those. And then all of this will apply to future work, allow us to do more. One thing noted on here that DeAnne and Lisa have been doing is engaging with tenants. And they can share a little bit kind of how they're going about that, because that helps them to determine what the needs are. When we're addressing, you know, even the hot water tanks, someone comes forward and says, our water's not hot enough, or our house isn't warm enough, or we have a draft. So yeah.
So you want me to go ahead
Yeah,
with
go
that?
ahead.
So a few of the things we do that doesn't require extra funding is, last year, DeAnne and I created, we created a little program for the tenants, and it's called Beat the Heat. In there is all sorts of little tips and tricks, you know, during the summer, close all your windows and your curtains. At that time, you open them at night, like just some basic stuff that some people just don't, you know, actually know.
Mhm.
We do pre-inspections every winter. We go into each home with a 24-hour notice to enter. We check all the windows, making sure there's no cracks, no broken windows, stuff like that. A new thing that we're just starting now, it's called Flip the Switch, which again is more of an energy savings tips and tricks for tenants that we discuss at our tenant meetings and stuff like that. And then the BC Hydro stuff and the new applications. And I think, do you have anything
Yeah.
you want to add
So
to
I
that?
just think that knowledge is power, and it's
Right.
key to lowering energy costs in in all our homes, and engaging with the tenants about the value of energy management and arming them with the tools and know-how to lower costs, resulting in more strategic energy use, right? That benefits us and them. So that's we tried to have a lot of engagements with our tenants, even if we're over there, the kids are mowing the lawn or something, we'll go talk to them. And Arno, yes, we fixed that, by the way. I just like that picture. Yeah, so working along with Trevor too, and with this funding that we just received is just absolutely wonderful. And with all these energy reports that we've had, as long as with Arno's as well, we will continue to, better our homes and engage our tenants as well. Because like I said, knowledge is power, right? So.
So one thing I'll just piggyback off on that is that during our winter inspections, we go in with our furnace filters, and believe it or not, I'm going to bet probably 70% tenants do not know how to change a furnace filter. They do not know to go buy them, that the society supplies them, and then we teach them how to change them. And then the following year, we do the same thing all over. Some tenants, yes, they're comfortable with it. Some tenants aren't. And the ones that aren't, we just do it for them. That's just a few of the things that help along the way. Like lots of people are actually afraid to change that filter. I don't know if they think it's dangerous or what, but that's where the Beat the Heat comes in. The Flip the Switch comes in, like these little tiny programs that we create so they can help us help themselves, really.
And using the recommendations from the EnerGuide process, meeting with the tenants, all that together, it makes sure that we're addressing what's actually needed. Because at the end of the day, AHMA serves the societies that are our members, and the societies serve their tenants. So the most important thing for Lisa and DeAnne is making sure their tenants are happy. And listening to them goes a long way. It also makes my job a little easier because I have to determine a little less when we know what the tenants want. So we all win.
Yes.
We did have a couple of questions in the Q&A, but I see that they actually have already been answered. So I just, you guys are so on top of it. I just wanted to give one last call for any final questions that anyone would like to ask. But if not, then we'll go ahead and wrap up. Yeah, so I just wanted to say thank you again so much, DeAnne, Trevor, and Arno for being here and helping us out with this webinar, sharing your experiences and your knowledge. We really appreciate it. Thanks again, everybody, and hope you have a great afternoon.
Thanks, guys.
Goodbye.
See you.
See you.